Have you ever wondered what's really going on, under the hood of the universe? Well, today we're going to crack open the source code of reality itself. From the device you're watching this on to the most distant galaxies, we are exploring the fundamental operating system that runs absolutely everything: physics. I mean, seriously, take a second and think about it. We use these incredible little gadgets every single day. We tap, we swipe, we talk into them. But how in the world does this little rectangle of glass and metal connect you to, well, everything? Now, you might be thinking, oh, it's circuits or computer code or the internet. And yeah, you're not wrong, but you're not fully right either. See, those are just the applications. The real answer, the real engine running the show, goes so much deeper. It's one fundamental idea that makes it all possible. That's it, physics. Every single thing your phone does, from the light on the screen you're looking at right now to the signal it's pulling out of thin air, it's all a direct application of the fundamental laws of the universe. So let's actually dive into this. To really get this, we're going to deconstruct the smartphone. Not literally, of course, but we're going to look at its most important functions and trace them right back to the specific branches of physics that make them happen. Let's start connecting some of these dots. Okay, first up, the camera. Every single photo you take, every video you shoot, it's all just a beautiful dance of optics. This is the part of physics that's all about light. And your phone's camera? It's a tiny little master of it. The lenses inside bend and focus light in just the right way, painting a perfect little image onto a sensor. It's not magic, it's just pure physics. And what about when you listen to your favorite song or talk to someone on the phone? Yep, that's where acoustics comes in. Physics explains how those tiny speakers can vibrate the air just right to create the sound waves you hear, and how the microphone does the exact reverse, turning the sound of your voice into an electrical signal. It's this amazing two-way street of sound, and it's all governed by the laws of physics. Have you ever noticed your phone getting a little warm, maybe after you've been playing a game for a while? Well, you just had a little run-in with thermodynamics. That's the study of heat and energy, and it's showing you something really important. Processing information takes energy, and a byproduct of that energy is heat. So that warmth you feel, that's just the sign of your phone's powerful little brain hard at work. But really, the true powerhouse of your phone, the one that makes almost everything else possible, is electromagnetism. This one is huge. It's the force that governs the electricity flowing from the battery and the light coming from your screen. It's the invisible highway that carries your Wi-Fi and cell signals right to your device. Heck, it's even the magic behind wireless charging. Seriously, without electromagnetism, your smartphone would just be a very, very expensive paperweight. So, we've seen all these different parts of physics firing on all cylinders inside our phones. But what is physics really? Like, what's the big idea that ties all of this together? Let's zoom out for a second and get to the heart of what this is all about. At its very core, physics is literally the study of nature. The name itself comes from the ancient Greek word physis, which just means nature. And that really gets to the point. It's all about our deep-seated human curiosity to understand the basic, fundamental rules that make our universe work. This quote just nails it. Physics isn't about memorizing a bunch of complicated equations. No, it's about understanding the why. Why does an apple fall down instead of up? Why does the sun shine? Physics is our attempt to reverse engineer reality itself, to figure out those basic mechanisms that make the universe tick. And because physics deals with these fundamental rules, it's not just another science. In a way, it's the bedrock. It's the foundation that all the other natural sciences are built on. It provides the underlying principles that other fields then take and run with in more specialized ways. And this just shows you how connected everything really is. Take chemistry. What is it really? Well, it's pretty much just the physics of how atoms and molecules interact with each other. Engineering? You can thank physics for every stable bridge and every skyscraper. Geology? Medicine? They all depend on the core principles of physics to make sense of their worlds. It is the ultimate scientific multi-tool. But this incredible body of knowledge didn't just appear out of thin air. It was built, piece by painstaking piece, over centuries, by brilliant and curious people who just dared to ask the biggest questions. So let's take a moment and meet some of the key architects of our modern understanding of the universe. You can kind of think about the history of physics like a big two-act play. Act 1 is what we call classical physics. This gave us the rules for the world we can see and touch every day, things like motion, gravity, and energy. But then, in the 20th century, the curtain went up on Act 2, modern physics. And that's when things got really wild. taking us into the bizarre realm of the super small with quantum mechanics and the unimaginably huge with astrophysics. So let's meet some of the stars of that first act. You've got Galileo, the rebel who pointed a telescope at the sky and completely changed our place in the cosmos. Then there's the legend himself, Isaac Newton, who supposedly saw an apple fall and came up with the laws of motion and gravity. We have to talk about Michael Faraday, who started as a bookbinder's apprentice and ended up unlocking the secrets of electromagnetism. And James Prescott Joule, who figured out that all forms of energy, heat, work, they're all connected. Each one built on the work of those who came before. And this is the beautiful part. The laws of physics are timeless. The same exact principles of gravity and motion that allowed ancient engineers to build incredible structures are the very same principles we use today to guide a rocket to another planet. From the simplest tool to the most complex computer, the same rulebook applies. So what's the big takeaway here? It's that physics isn't just some abstract subject you study in a classroom. It is the invisible architecture holding our entire world together. It's the deep grammar of the universe, and we are just now getting fluent in its language. We've taken these rules and used them to build our modern world, from the phone in your hand to the spacecraft exploring our solar system. But the more we learn, the more we realize how much we still don't know. The universe is still packed with mysteries, things like dark matter, dark energy, maybe even other dimensions. The rules are out there, just waiting for us to find them. The only real question left is, what new questions are we going to ask next?